Hello, my dear J warriors. I hope I'm audible and visible. Do let me know in the chat box right away right now. And today's session is our flash session where we are going to see the most repeated concepts and we will see the application with PYQs. So you are then going to get the confidence that yes, these concepts, they are very important so that you will not miss it for the next attempt. Number one. Number two, when you see them actually being applied, that is the best way to understand the concepts. And what better way than taking PYQs? And obviously, all of this comes with your tricks and tips and everything as we solve the problems, right? So let's get set, go. I hope everybody is live. I hope everybody can see me, hear me properly. Just 1 second. Let me just get my chats up. Just 1 second. Yes. Perfect, perfect, perfect. Almost there. Okay, yes. So let's begin with the class with full josh, full energy. And before we proceed, you need to do your daily ritual of smashing that like button. Yep. NCERT lines, we did almost all the chapters, unmatched matter. Now, I also want students to, concentrate on 12th standard portions this week. And next week, yes, we'll be doing a lot of stuff for boards because boards are going to be around the corner. So don't worry about it. Yeah. The results are not yet out. Don't worry. Yes, Darshan, Captain is ready to snap like the Iron Man. And all my Avengers are here, hopefully. Hello, Denson. Hello, Priya. Let's begin with the lecture. And before we go ahead, let me also tell you that there is a offline plus online free camp going on for 11th standard backlogs. You can also join it even though you are 12th or dropper. But if you have your 11th standard friends, please let them know that it is starting today. And not just that, it is available in offline mode and it's completely free of cost. You can see it's there in Delhi, Pune and Muzaffarpur center where we are conducting it. And not just that, if you want to attend it online, the link is there in the description box. You can share that link or share this video and ask them to register for absolutely no cost. You can see it right over here as you're watching this particular video. Okay, it's there. You can see that. Online English, you can see that. You click this link, you can see it's for absolute zero price. You can even watch it. And you can see if you want to join the offline centers, click on any of these links. Okay, so that's for your 11th standard backlogs. Okay, so let's begin with the first few concepts of electrostatics and Gauss law. So in electrostatics and Gauss's law, what are the usual kind of questions that JEE Mains has been asking, or what you can expect it for the next attempt? See, one of the things that they ask is about electric field, also electric potential. Having said that, for both of them, you should know the field and the potential values for all the geometries. That is what they concentrate on when they are asking you the electric field and electric potential. Very few problems relate field with potential, but individually finding where is the field 0, where is the potential 0, these questions are very, very common. Basically, find where is E0 or find where is potential 0, or where the potential is 0, what is the field? Those questions are also very, very common. Okay, so with regards to electrostatics, field and electric potential. Another concept that they focus on, by the way, you should know the basic meaning of electric field, right? Electric field and force, they are related with this formula. Electric field is the force acting per unit charge and electric potential is the potential energy per unit charge. You can also write this as the work done to get it from infinity to the point upon that test charge, right? That is the value of electric potential. Great. But when you see some more problems, you will get some more understanding. This is also a very important formula where they focus on work done by the conservative force is the negative change of the potential energy, Also, the work done by the external force is the positive change of the potential energy. A lot of people misread whether it is work done by electric force or work done by conservative force, and that's where you face a lot of issues. Keep that in mind. When you have to find the change in the potential energy, you can use many of the forms like final energy minus initial energy, or you can also use charge into the voltage difference. That also works. Keep that in mind. Yeah. Similarly, there are also energy conservation based questions. Like you take a charged particle and you accelerate it. A charged particle is accelerated through a potential difference. And what happens because of that? It gains kinetic energy, and that kinetic energy is given by half mass into v square. This concept not only comes in electrostatics but also in some of the questions of modern physics, if you realize. Some of the concepts of modern physics. Is that right? Very good. Then you will also see that there are couple of questions on dipoles and dipoles in a field and field due to a dipole and all these things. You should know that when you have a positive and equal amount of negative charge, the field lines go like this. So if you are on the axis, the field is strong and it is given by 2kp by r cube. And if you are over here, then the field is slightly less. It is just given by kp by r cube. That is how the field looks like. This is a field due to a dipole. But if you take a dipole and place it in somebody else's field, then you will experience a torque given by P cross E, and the potential energy is minus P dot E. That is what you get for a dipole placed in somebody else's field. These questions were also very common in the last few years and even in this particular shifts, that if you remember. You will also see many problems. Where let's say for example, some kind of equilibrium or potential energy of the system, or find the field due to many charges. These are very common. Like you have a triangle, you have a square, you have a line which is made of 3 charges, or you have a hexagon. These are very, very common geometries where questions are asked. What they will ask you, kind of questions: potential energy of the system. When they say potential energy of the system, each pair has to be taken and you find individual potential energies and add them up. So potential energy of the system is the sum of the potential energy of each pair of the charges. Sometimes they ask you potential at a point. It's potential due to each charge and you add them scalar wise. No vector addition. Don't worry about the direction at all. Hello Abhishek, this is not recorded, this is live only. Okay, right, all right, cool. Concentrate on the class. How does it matter whether I'm talking to you right now or does not, or I'm not talking to you? Just concentrate on the class, my dear warriors. Okay, so don't spam. Moving on. If you talk about field wale questions, you will be asked field at a particular point. Then you have to use vector addition. vector addition, like take a point here or taking a point here, or the field at this point due to other three charges, field at this point due to other three charges, field at this point due to other three charges or two charges. These questions are also very, very common. Cool. Okay. Now, if you move on to Gauss law, direct application based questions come on Gauss's law, where you have to know that the flux of the closed surface is the total charge inside by epsilon naught, and this is cyclic integral E vector dot area vector. Here you should know this fact that this is because of inside and outside charges both. This electric field on the left hand side is because of inside and outside both, but here it's only because of the inside charges only. Inside charges only. Keep this in mind. These questions have been asked in many ways, and often they ask these questions on the geometries of a cube. Like you should know, if you have a cube and if a charge is placed here, then what is the flux through this part? Or sometimes you might be given again a cube, and a charge is placed here, then what is the flux through this part? So these questions are also very, very common. Shapes are given, you have been asked what is the flux through each of that part, okay, one face of that shape. These are also very common. Yeah. Now let's see some questions based out of it, because you will see that whatever I have been telling you is actually true, and you will see that many of the questions even this year were one of these patterns only. Ready for the questions? Light up the chat box. I want to see the Josh. NCERT lines I just finished, my dear warriors. Most of the chapters are done. So during the boards we will be doing more of NCERT, more of boards as well. Don't worry about it. Okay. So let's have a look at the models of the actual questions via examples. Is that right, Abhishek RS? Let's have a look. Here's the first question. Two charges Q and 3Q are separated by a distance of r in the air. At a distance of x from the charge Q, the resultant field is 0. I just told you, field 0, potential 0, these questions are common. The value of x is how much? Okay, so let's have a look. So we will first start by drawing the charges Q, and let's draw the charge 3Q. Okay, let's connect them by a distance of r, and there is a point somewhere, let's say I call this as x. So due to this charge there will be an electric field here, and the remaining distance will be r minus x, and due to this the field will be here. These both fields will be equal and opposite, so that their net field is 0. You can see that over here, the net electric field is 0. So what is the electric field due to the 3Q charge? This way, it will be K into 3Q divided by this distance, which is r minus x whole square. What is the field due to Q charge over here? It is K Q divided by what is the distance? X. So x square. Obviously, both of them must be equal. Is that right? Okay. Both of them must be equal. So K cancels, Q cancels. So 3 is remaining. So 3 by r minus x whole square is equal to 1 by x square. Take roots on both sides. So root 3 by r minus x is 1 by x. Cross multiply. So root 3 into x is equal to r minus x. Bring x over here. So root 3 x plus x is equal to r. So x common, r upon 1 plus root 3. R upon 1 plus root 3, which is option number C. So always these kind of questions involve finding the fields due to each one of them. Distance will be given, remaining distance you calculate or assume, or this distance also you assume. Equate the magnitudes, many things will get cancelled. Root is also involved, and then you get the final answer. Is that understood? Hello Success Seek PR, welcome aboard. Yes, whatever flash series or whatever lessons left to study plus mock test, enough for bit side. Abhishek, flash series plus the one shots, whatever are there, zero to superhero. If you can watch that, please watch it. There is a lot of time for bitsat. Okay, there is a lot of time. Okay, you can definitely, yeah, do it. Okay, okay, great. Okay, results, I don't think so. Let me see. Just checking it out. Meanwhile, let's go ahead to the next question coming up on your screen. Read this question. No, the results are not yet out. Don't worry. Results. The results have come, is it? (10:30). Okay, so we have time. We have time. Okay, let's do it fast. I know then after the results come, then you will not be in the mood to study. So let's quickly start doing the problems. Ready for it? Ready for it? Okay, come on. Everybody is focused on the class. Everybody is focused on the lecture. Nobody is focusing. Nobody is going to focus on the JEE Mains result right now because there is still some time. Okay, we have an hour. So let's solve more problems. Let's not waste this time. You will be like, sir, my mood is not there. Sir, I'm not able to think. Yeah, all that things. No, don't say that. Even that 1 hour which you waste now, you will regret it later on during the second attempt. You will be like, oh my god, I just needed 1 hour to do this. I wish I could have got that 1 hour. What about this question? There is a charge 2q. There is a charge 2q here. So this inside cube which is there, the flux through that will be 2q by epsilon naught. If you look at the outside cube, this 2q and 3q together will give the total flux. Isn't that right? So the total flux through the outside part will be nothing but 3q plus 2q, which is 5q by epsilon naught. So obviously now take the ratio. Answer is in your calculations right over here. Q cancels, epsilon cancels. So what will it be? 2 by 5. So 2 by 5 or 5 by 2, one of them will be the answer. Yes, that is the correct answer. Option C. Next question coming up on your screen now. Yes, Priya, if you want, you can definitely watch it. An electric charge of this much is kept at the origin of a XY system, coordinate system. P and Q are at this point and this point. What is the voltage difference between the points P and Q? Here, what you do, see, this is also JEE Mains question. This was asked now this year. So what you do in this case, I told you, right? Finding potentials, finding field, very common model of question. First point P is root 3. That means it is here. P point is root 3. Q point is root 60. Q point is root 60. So for point P, when you want to find the potential, Vp will be K, charge is the same, divided by the distance. How much will the distance be? Root 3 square plus root 3 square, which is going to be Kq divided by 3 plus 3 is 6. So it will be root of 6. That is potential at point P. How did I write it? Distance formula or distance from the origin using Pythagoras. So, okay. Potential at point Q is Kq divided by this direct distance is just root 6. Best part, both of them are just equal. If they are equal, what do you think will the difference be? It will just be 0 volts, right? It will just be 0 volts, isn't that? They both are equal, so there is no potential difference at all. Got it? Let's go to the next type of question. You can see all these are repeated models. Very commonly asked questions are from these models only. So if you practice them, you're automatically practice for the next shift. Okay, great. Great. Awesome. Awesome. T. Akash, why don't you do one thing? Leave a comment after the session is over. I'll definitely have a look at it properly, okay? Because otherwise, when I'm thinking I'm doing something, it is very difficult to think otherwise. Okay. Considering a group of positive charges, which of the following statement is correct? Assuming a group of positive charges. So assume a group of positive charges. Net potential cannot be zero, but net field can be zero at a point. Yeah, it's quite possible. Just imagine this. Imagine there are just even two charges. You can definitely find a point in between them where the net field is zero. The net field between this and this is cancelling out, but the net potential will be one positive term plus another positive term. So it will become another positive term. That means it is definitely not zero. So A option is definitely correct. A option is definitely correct. Net potential can be zero. No, it can never be zero, because each charge will give a positive potential. Positive and positive will add and cannot cancel out. So option B, net potential can be zero, is a wrong statement. Both the potential and field can't be zero at a point. I just proved it to you that field can be zero. So both net potential and net field, no, net field can be zero due to multiple charges. Both the potential and field can be zero. No, you can see that potential can't be zero no matter what you do. So the word potential is wrong. Potential will be there no matter what you do. Okay, great, awesome, awesome. Thank you, Kim. Thank you. It means a lot. A lot of students from Northeast watch these classes, and it means a lot that we have something that we can do for all the students throughout the country. Moving on to the next one coming up on your screen. There is a charge, it is moved from point P to S in a uniform field of 30 along positive x-axis. You can see field and potential and work done related questions. I told you, right? Potential field questions come. If coordinates are given, the work done by the field is how much? If you notice, the field is directed along the positive x-axis. This is how the field is directed along the positive x-axis, 30 Newton per Coulomb. The points are somewhere and all. One point is here, one point is here. Point P is over here, point S is over here. No matter how you go, the electric field will only do work in the x-axis. So what matters is how much coordinate you are changing, only in the x direction. So the delta x, because work is only done in the x-axis, because there is no field in y or z direction. Coordinate of P is 1, coordinate of Q is 0. So the difference is basically 1 minus 0, which is 1. 1 minus 0, which is 1. Perfect. So now what do we do next? We have to find the work done by the field, right? So work is force into displacement. Force is charge into field into displacement is delta x. Charge is 2 into 10 to the power minus 2. Field is 30. Delta x is 1. So 2 into 30 is 60. 60 into 10 to the power minus 2 is 0.6. 0.6 or 600 millijoules. That's what you can put it as. But I think the question is, it has moved, from this point to this point, from 1 to 0. So technically it should be 0 minus 1, the displacement. Technically it should be 0 minus 1. That's why you'll get the minus sign. So displacement sign wise will be negative. 0 minus 1 will make it minus 1. So technically there is minus over here, and that's why this will be also minus, and that's why you will get minus 600 millijoules. Is that right, everyone? Yeah. Akhil, the JEE results will be out after some time at 10:30. So till 10:30, think as if nothing is there except for this session in the world. If you can control your emotions and your mind, that means that your second attempt, you will do mentally much better than the first attempt, because your mental state of mind plays a very important role. No matter what you study, if your state of mind is bad, you will lose up many marks. If there is a cube, dimension, charge, center, 4L square, I told you, right? Find the flux through a surface. This is also a common question. Common question. Yep. Let's have a look. First of all, let me draw that cube for all of you. Let me draw that cube for all of you. This is 2L. This is also 2L. This is L. Something like this. Okay, this is 2L, this is also 2L, this is L. On a surface area of 4L square, 4L square is this one. 4L square is basically this one. At the center of it, you are putting a charge. At the center of it, you are putting a charge on the top face. Everybody is able to visualize it? Okay. What is the flux through the opposite surface? Meaning, they are asking you, guys, through this bottom surface, through the opposite of this is bottom, right? So it will look something like this, I guess, like this, yeah, something like this. So through this bottom surface, what do you think is the flux? What do you think is the flux? That's the question. So how do you do that? Now what you do is imagine one more cube on top of it. Yes, imagine one more cube on top of it, something like this. You know why I did that? You know why I did that? Because now that charge which is there, Q, that charge will come at the center of a big cube. That charge will come at the center of a big cube, and the bottom face is this one. The bottom face is this one. Just visualize this. See if you are able to visualize this, my dear students. So what will happen? If you take any one surface, 1/6 of the flux will go through it. 1/6 of the flux will go through it. How do I know it is at the center? Because this is 2L, this is 2L, this is L. That will be also L, no? That will be also L. L plus L, 2L. So now it has become a big cube of side 2L. Any face is 1/6 because there are 6 faces. So 1/6 of the total flux. So Q by 6 epsilon naught should be the answer, which is option D. Is that right? Everybody? Everybody understood? Yes, Maharaj, the site can't be reached because of obvious reasons. Everybody is trying and they are also going to update. It will take some time. Hold on. If you take a wall which provides some electric field and a particle is being suspended through some length and remains steady, this is also very repeated. If you see old question papers also, this kind of question has come. So what happens is you have a charged sheet. You have a charged sheet like this, and that will give you some electric field. That will give you some electric field. So that's what I told you. You should know the electric field due to all the geometries. A uniformly charged wall produces the electric field 2 into 10 to the power 4 Newton per Coulomb. Now what happens is there is a thread which is like this, and it will experience many forces. One such force is the force due to electricity, so it will be QE. It will be just QE. Another such force will be due to gravity, and that will be over here, that is nothing but mg. The last force will be the tension force. And how much angle is it maintaining? That is not given, but they have given the lengths. That's enough for me, because if the length is 20 centimeters and the distance from the wall is basically 10 centimeters, this line now completes and makes it a right angle triangle. This is hypotenuse, this is half, that means this should be 30 degrees. This should be 60 degrees. So naturally if that is 30, so that means even this is 30 degrees. This is 30 degrees. So now you just write the equations FBD wise. So a tensions component, which is tensions cos 30, will be mg, and tensions sine 30 component will cancel that QE. So when you divide both of them, sine 30 by cos 30 will make it tan 30, and QE by mg. and QE divided by mg. Tan 30 is nothing but 1 by root 3. All other values you know. Charge, you don't know, that's what you have to find. Electric field, you know. Mass, yes, I think you know, 2 grams. G, you can take it as 10. Solving this, you will get the value of Q. Solving this, you will get the value of Q. Everything is known. You shall get it as 3 by or 1 by root 3 microcoulomb or something. Is that okay? Understood? Clear how to solve this question? So, it involves free body diagram. It involves the concept that force on a charged particle is Q into the field. And once you know the free body diagram, balancing the forces. This has been particularly asked. This model has been repeated many years. So expect a similar model in the coming shifts in April attempt. Electric potential on the surface of a nucleus is how much? This is a very straightforward question, but it has been asked in different ways at many different places. You open up BitSat papers, CUET papers, you will see that. Yep. So, if you talk about the atomic nucleus, there are many positive charges and it is uniformly distributed. So, the total charge on it is plus Z, which is atomic number into E. So, if you are on the surface and this radius is basically R, the potential on the surface is Q divided by R. So that's it. So potential is K, which is 9 into 10 to the power 9. Charge Z is 50. Each charge will be 1.6 into 10 to the power minus 19. Whole thing divided by distance, that is 9 into 10 to the power minus 15. This is centimeter, meter you convert it. So 9 cancels, 16 5s are 80. So it will be 8 into something. So maybe the power of 10 is just 1. So potential comes out as 8 into 10 to the power 6 volts. That is the answer. Got it? Yeah, this question came in your shift, Satish. So a very, very simple question. So like I've been saying, you should know the potential due to different geometries. They have been asking this. Okay, if you want to watch my formula session, you can revise all those formulas as well. Right? Moving on to the next one coming up on your screen. Now here you have a combination of capacitors, resistors and EMFs based questions and KCL and KVL based question. See, simple things, let me keep it over here. If you talk about series, right, and then parallel combinations. First, let's talk about resistors. Then let's talk about capacitors, and then let's talk about EMFs. Resistors, capacitors and EMFs. How do the formulas look like? If you have resistor, you just do R1 plus R2 plus R3 like that, correct? If it is in parallel, you do 1 by R1 plus 1 by R2 plus 1 by R3 like that. You take the reciprocals and add. In case of capacitors, it is exactly opposite. So it is 1 by C1 plus 1 by C2 like that. For parallel, you just add it, C1 plus C2 like that. For EMF, it is E1 plus E2 like that. And internal resistance also gets added, R1 plus R2 like that. Okay. But when it is in parallel, then it looks something like this. E1 by R1 plus E2 by R2. That is the equivalent EMF. Whole thing divided by 1 by R1 plus 1 by R2. You add it till the N resistors. Similarly, equivalent resistance is 1 by R1 plus 1 by R2 plus 1 by R3 till the last term. That's how you find the equivalent internal resistance. Correct. And one of the most common questions which were asked especially in capacitors is exactly this one, where you have a capacitor, you charge with a battery, then you take that capacitor, disconnect it from the battery. So right now there is charge over here, maybe some charge is there over here. Okay, this capacitor got charged, and then you connect it to an uncharged capacitor, and then what happens is the charge gets distributed in both the capacitors depending on the capacitance. Maybe one of the charge goes here, and then question is find the voltage, find the charge, find the energy loss, all these kind of questions. Remember, from this step to this step, it's the charge which is conserved. It's the charge which is conserved, and it remains conserved even in this step. The charge is conserved even in this step. The charge can't go anywhere. And finally, these two capacitors are in parallel. You can assume it like one single capacitor, but in parallel, capacitor in parallel. And from this step to this step also, the charge is the same. The charge is going to be conserved. If you remember that the charge is conserved, you can solve the problem very easily, because you also know C parallel is just your C1 plus C2. Is C1 plus C2. So now finding anything becomes very easy. Like for example, potential. Potential will be nothing but Q by C parallel. Energy will be half Q square by C parallel. So that kind of things. So you can find potential, energy. If you know the initial energy or potential, you can find the potential difference, energy difference, energy loss, anything. So that is how these questions are supposed to be solved. Yeah, cool. Hello Shreya, welcome. Then when you talk about Kirchhoff's current law and voltage law, many students have this confusion. Like say for example, you have a resistor, you have a battery, you have a capacitor, and then you again have a resistor, let's say like this, and then let's say you have a battery, and then let's say you have a capacitor, something like this, and maybe the current is going like this, I1 over here, and is going like this, I2 over here. Okay, and let's say this is the positive terminal, this is negative, this is negative, this is positive, this is C2, this is C1, this is E1, this is R1, this is R2, this is E2. So sometimes you might have to travel from this point to this point and apply Kirchhoff's laws. Well, first of all, if you have to apply Kirchhoff's current law, I1 is coming over here, I2 is going over here. So here also the current coming in is I1. So out of I1, I2 goes there. So here let's say I3 will go out, and obviously I1 will be equal to I2 plus I3. I1 will be equal to I2 plus I3 at that junction. That is Kirchhoff's current law. If you talk about voltage law, if you start from this particular point A and go till this particular point B, from point A to point B, then potential at point A, whatever it is, you go along this path, you encounter a resistor, and the current is going in the direction of you traveling. So there will be a drop in the voltage. Whenever you go in the same direction of the current in a resistor, you drop the voltage. Current goes from high voltage to low voltage. So current goes from high to low, so there is a drop. So you put minus I1 R1. So at A, there was some voltage, you drop by some amount, then you go to this battery. This is positive, this is negative, you are going from high to low, so there will be a drop of the voltage, so minus E1. Here, you are going from positive to negative, again there is a drop, so minus whatever is the charge divided by C1. Then as you go over here, what do you get? You get this resistor, again you are going in the direction of the current, so there is a drop of minus I2 R2. Here you encounter a battery, you are going from negative to positive, so it will be plus E2 from low to high, so it will be a jump. And here you are going from negative to positive, so low to high, so it's a jump, it's a raise, so plus Q2 by C2. So that's how you write the equation, and when you reach over here, you get point B. So that's how you write Kirchhoff's voltage law equation when you go from one point to the other. By chance, you come back to the same point, then what happens? This and this becomes same. This and this becomes same. So the sum of all these things becomes 0. So the sum of all these things becomes 0 if you come back to the same point, that is point B is the same as point A. Otherwise, this is how the equation will look like. Is that okay? Yep. Yes, G1, there will be a YT batch for JEE 2025 too. Definitely. I can see a lot of you are just tensed more than the lecture. Everybody is like concentrating on the result. Please guys, concentrate on the class. two identical capacitors have same capacitance, like I told you. One of them is charged to some voltage, other is charged to potential 2V. Negative ends of both are connected together. When the positive ends are also joined together, the decrease in the energy of the combined system, just like I told you before. Just like I told you before. So let's have a look. Let's have a look. Two capacitors have some capacitance C. One of them is charged to a potential V. So you take a capacitance, you charge it to voltage V. The charge on it will be CV. Okay. Other one is charged to potential 2V. So you take the other capacitor, you charge it to a potential of 2V. So on that, the charge will be 2CV. The negative are connected together, positive ends are joined together. So just imagine this. This capacitor and this capacitor, both are joined. This is plus 2CV, this is minus 2CV, this is plus CV, this is minus CV, something like that. Plus 2CV, minus 2CV, plus CV, minus CV, you join them together. What will happen? The total charge on the system will remain conserved. This charge is 2CV, this is plus CV, so total charge is, how much? 3CV. CV plus 2CV is 3CV. That will remain constant. It can't go anywhere. These two capacitors are in parallel. You combine them together. And make it into one single capacitor. C plus 2C will make it 3C capacitor. The total charge on it will be 3CV. Is that right? Perfect. Now what will be the energy? The energy will be half Q square. So 3CV square by capacitance, which is 3C. 3C will get cancelled, 3 will remain. So 3CV square by 2. That is the final energy. 3CV square by 2 is the final energy. Just check this out. Yes, perfect. Then check out the initial energy. Here the initial energy will be half CV square. Here the initial energy of this capacitor will be half C into 2V whole square. You know the initial energy, you know the final energy. Find the difference, you get the answer. You find the difference, you will get the answer. Got it? That's how these questions are meant to be solved. This was asked in this particular year itself. If you take a wire of resistance R, length L, cut it into 5 parts, and these parts are joined parallelly, then the resultant will be how much? This was also a commonly asked question where you cut wire, find the resistance, you elongate a wire, find the new resistance, join wires, find the new resistance, all these things. So the moment you take a resistance of R and cut it into 5 parts, each part will be R by 5. Now when you take that R by 5 and connect it in parallel, my dear warriors, something like this. So what will be the new resistance? 1 by Rp will be 5 times 1 by each resistance is R by 5. So that will make it 25 by R. So the parallel resistance will be R by 25. That is the answer, R by 25, which is option number A. Correct. Very good. Shall we move ahead? Alright, next one coming up on your screen. This was in JEE Mains 2023. Arrange the following in the increasing order of power. See, power is I squared R. So if you have to arrange it with increasing order of power, it's basically you have to arrange it in the increasing order of the equivalent resistance. As simple as that. Now if you see all permutation combinations are there, here this is in series, so this will be the highest resistance. Because it is in series. Whenever you are in series, you will get the highest equivalent resistance. If you look at this is completely in parallel. So in parallel, you always get the lowest of the resistance. So C will be lowest, D will be highest. C will be lowest, D will be highest. I can see only one such option like that. C is the lowest and D is the highest. I don't even have to compare other two. I directly can mark it as option number C. Did you see that what I just did? I directly marked it as option C. That is the trick involved in this question. Otherwise, many students try to find equivalent of this, equivalent of this, equivalent of this, equivalent of this, power of this, power of this. Why do you want to find power? Power is directly proportional to resistance, I squared R formula. So, by common sense, series has most resistance, parallel has lowest. You see only one option is there like that. If there are more options, then I will have to solve these two. Otherwise, I don't have to. Looking at another question, find the current flowing through R2. R2 is here. Okay. This is also a beautiful question. Maybe I can duplicate this slide by some way. Yeah. Okay. So what you do in this particular question is, notice these two resistors are in series, 2 and 4 will make it 6 ohm. This 6 and this 6 are in parallel. This 6 and this 6 are in parallel. So that will make it, parallel will make it 3 ohm. Is that right? This 3 ohm and this 3 ohm are in series. This 3 and this 3 are in series. So let me just redraw it. So something like this. This is 4, this is 8, that is 2, this is 3, this 3 and this 3 are in series, so that will make it 6 ohms. Now this 3 and this 6, they are in parallel, so the equivalent will be 3 into 6, R1 R2 by R1 plus R2. So it will be 18 by 9, which is 2 ohms. Now this 2 ohms and this 2 ohms are in series again. This 2 ohms and this 2 ohms are in series again. Observe it carefully. This 2 and this 2 are in series. So that will make it again 4 ohms. This is also 4 ohms. And this is 8 volts. The equivalent circuit will be just one battery of 8 volts and one single resistance of 2 ohms, because 4 and 4 are in parallel, equivalent will be 2 ohms. Now go the exact reverse way now. In this circuit, the current will be 8 by 2, which is 4 amperes. That 4 amperes, you can see, will get distributed equally, 2 amperes here, 2 amperes here. Correct? Equally it will get distributed with both the resistors. Here what will happen? 3 and 6, right? It will be in the inverse ratio of the resistance. Here it will be in the inverse ratio of the resistance. So that 2 amperes which is there will get divided in 1:2 ratio. So 1:2 means divided into 3 parts. 2 by 3, 2 by 3, 2 by 3. Out of that, 2 by 3 amperes will go here. The remaining 2 into 2 by 3, which is 4 by 3, will go over here. 4 by 3 amperes will go over here. The 2 by 3 amperes will go over here. Are you able to visualize it? Then in that 6 ohms, which is this branch, this is 2 by 3 amperes. That will get split here and here. Each of them is 6 ohms. So half here, half here. So 1 by 3 amperes here, and obviously 1 by 3 amperes over here. So through R3, R2 and R1, it's 1 by 3 amperes, which is option B. That's how you solve it. What a brilliant question. What a brilliant question. Yes, GK, definitely I'll be taking classes for advanced. Definitely. This is a JEE channel. Obviously, we'll have to take it for everything, right? So these are all the questions which are highly repeated, most important for your second attempt. If especially you want to boost your score, you have to go through these questions. Next one coming up on your screen, again finding equivalent resistance between points A and B. If you immediately see this question, you will think it is complicated, but then a closer look will make you realize this part is actually a balanced Wheatstone bridge. Balanced Wheatstone bridge, and out of that, this is the resistor which is completely useless. This is the resistor which is completely useless, so forget about it. So you have this, and you have this. So essentially you have basically 4 and 4, which makes it 8, and then this 4 and 4, which also makes it 8, and at the bottom you have 16. Just 3 resistors in parallel, 4 and 4. So you can see this and this are in series, this and this are in series, and this is one single resistance, and all of them are in parallel. So 1 by R equivalent will be 1 by 8 plus 1 by 8 plus 1 by 16. Solve it and see how much do you get. You should get the answer as, I think, 3.2 ohms. Solve it, you will get it as 3.2 ohms. Understood? Yep. The result will be out at, 10:30, not now. I know that you guys are anxious. We will meet now very soon. We'll talk about results. As shown in the figure, the network of resistors, 24 volt, internal resistance 3 ohm, current in the resistor R4 and R5 is how much? Okay, let's find out the equivalent resistance. These two are in parallel, so 1 ohm, this is 2 ohms, this is 20 and 5, right? So these two together will be 20 into 5 upon 20 plus 5, which is 25. So it is 100 by 25, which is 4 ohms. So what is the equivalent resistance? 1 plus 2 plus 4 plus this 2, and this 3 ohms will be over here. 3 plus 4, 7, 7 plus 2, 9, 9 plus 3, 12 ohms is the total resistance. What will be the current? Voltage divided by the resistance, which is 2 amperes. So where is that 2 amperes going? The 2 amperes is coming here. It will also go here, and it will get distributed here. In what ratio? 5:20, which is 1:4 ratio. So this will be 1:4 ratio. That's how it will be getting divided. So current will get divided in the ratio of 1:4. So the current is 2 amperes. So 2 has to get divided in the ratio of 1:4. Divide 2 into 5 parts. Divide 2 into 5 parts. So 2 by 5, and the remaining will be 4 into 2 by 5, which is basically 8 by 5 amperes. This is 2 by 5 amperes and 8 by 5 amperes. That's how you divide the currents. So that is the answer. 2 by 5 and 8 by 5. Where you go? Yes, option C. More resistance will have less current, less resistance will have more current. Cool. Got it? Alright. Moving on to the next question coming up on your screen. If you take a parallel capacitor, 2F charged to a voltage, energy stored is E. Again, now you connect it to another capacitor in parallel combination, energy stored in the combination is E2. Exactly like the previous one. That's it. I told you, common model, you connect capacitors, find new energy, find the new voltage. So a parallel plate capacitor of 2 farad, this is 2 farad, and you connect it to a voltage of V, right? The charge on it will be CV, so it will be 2V. Then another capacitor is connected to, this capacitor is now connected to uncharged identical capacitor in parallel combination. So you take this capacitor, the charge on it is plus 2V and minus 2V, and you connect it to an uncharged capacitor, uncharged identical capacitor. So now these two capacitors are actually in parallel. You can just take it as 2C capacitance. Charge will remain conserved, so this will also have 2V and minus 2V charge. This charge is conserved. It is conserved. It can't go anywhere. So now you can find the energy over here. The final energy will be half. The final energy is called as E2, I think. Yes, E2 will be half. Capacitance is 2C into voltage is not known. So half charge square by C. So 2V square by 2C. Okay, so this will become 2 square is 4 and V square by 2 into 2. Capacitance itself is 2, so again 2. So this will become V square by 2. So you can find E1 also identically. Again over here, you can find E1 also. It is just nothing but half CV square. C is 2, V square is V. So it will be just V square. So V square by 2. So 1:2 ratio will be there. Perfect. 1:2 ratio will be there. Got it? That's it. Then This kind of question where you insert a dielectric slot. Yeah. Everything looks like 10 standard sums. I'm in class 10, I can solve. Then J is so easy. Yes. Sanjeevna, Gauri Shankar, we don't know whether J will be so easy by the time you come to 12th standard. Maybe NT is giving the benefit of the doubt that the students are also were affected by COVID and all of that. So maybe J or NT has been a little bit lenient because syllabus is reduced. Everything is very normal. We don't know after 2 years what might happen. Who knows, right? So it's better to be prepared than be sorry. Yeah, cool. Let's go. Slab of dielectric constant K has some area and parallel plates thickness 3/4 d by d is the separation capacitance. When the capacitor is inserted is how much? Okay. So when such problems come and you are inserting a slab of thickness 3d/4 of dielectric constant K, this is air, so this will be just d/4. The equivalent capacitance is given by epsilon naught area by first distance is 3d/4 divided with the dielectric constant which is K. Next distance is d/4, write it as it is, and then divided by the dielectric constant of that medium. If there are more layers, you keep adding the distance and divide it by dielectric constant. That is an easy way of doing these questions. So how much will it come out to be? 4 will go on the top. So 4 epsilon naught A, even D is common. In fact, yeah, D is common. It will be 3/K plus 1. Epsilon naught A by D is C naught. So 4 times C naught by 3/K plus 1. That should be the answer. So you can take LCM and all that. You will see answer is option number A. This is nothing but option number A. You can see that. You can take the LCM. K will go on the top. Right? Very good. Excellent. Let's move to more questions which are going to come up on your screen. Here it is. Charge on the capacitor connected in the following diagram is. There is a battery, 4 resistors and a capacitor. Capacitor will block the current. So no matter what you do, the current will go like this. It will get partially divided here and here and here. And again it will collect back over here and come back. No current will flow in the capacitor. So it's as if these 2 points are just not connected with each other. So if you want to find the charge on the capacitor, you should know the voltage difference between the points A and B. If you want to find the voltage difference between points A and B, you should know the voltage of point A and voltage at point B. To know the voltage at point A and voltage at point B, you should know the drop of the voltage from here and here, because this point is at 10 volts. This is at 10 volt line. You are dropping by some amounts. So what is that amount by which you drop? If you know, you can find this and this point's voltage. To find that, I need the current. To find the current, I need the resistance. So that's how lengthy this question was. Yep. So how does it look like? My dear students? So you start. Okay. You start with finding the equivalent resistance. This is 2, this is 1. So this is 3 ohms and the other side is 6 and 4, which is basically 10 ohms, right? And these two, I hope I'm correct. Yeah, these two are in parallel. These two are basically in parallel, correct? So now you find the equivalent resistance. So R equivalent of parallel will be nothing but 10 into 3 upon 10 plus 3, which is 30 by 13. Then what you do, find the current. So the current is going to be voltage divided by the resistance, which is 30 by 13. This will become 13 by 3 amperes. Then you find the currents which are getting divided. Then what you do, you find the voltage at this point. How? The voltage at this point will be, at this point it was 10 volts. You're dropping it by minus whatever is the current, I1 R1. R1 is 1 ohm. Then you find the voltage at this point. How? This voltage 10 minus I2 into R3. R3 is basically 6. Then you find the difference of the two. Then you take this guy and subtract. That will give you the voltage difference. Then substitute it here and then calculate it. That is the procedure. That is the procedure. Understood? So it's quite a lengthy process, but doable. It takes some time. You can definitely do it. Another simple question which came in JEE. Combination of capacitors. You can see not many complex questions are coming. It's direct series parallel. It's like JEE has lost its charm. Yep. And how do you do this? How do you do this? All the three capacitors are in parallel. All the three capacitors are in parallel. The combination has a total charge of 100 microcoulomb and the voltage is 10 volt. So C equivalent will be nothing but 2 plus X plus 3 microfarad. And the charge is C equivalent into voltage. The charge is 100 micro. C equivalent is 2 plus X plus 3 micro and voltage is nothing but 10 volts. So 10 cancels. So you will get this. So 10 micro also cancels. 10 is equal to 2 plus X plus 3. So X should be 5. Just check it out. Oh, sorry. Something is wrong. Something went wrong maybe, or maybe the answer given over here is wrong. Okay, so one of them, but otherwise the procedure is correct. So this is 2 plus X plus 3, perfect. This is Q is equal to CV. C equivalent is 2 plus X plus 3 micro into voltage, which is 10 volts. 10 cancels. This is 10. So 2 plus X plus 3. So 2 and 3 becomes 5. 10 minus 5 is 5. So X should be equal to 5. Just check this out. Yep. Just let me know if you have got the result as of now, because I'll be going live again for your results. Okay, I'll be going live now because I can see a lot of people are impatient. So I think the last few questions are remaining. Equivalent resistance of the following network is, see, if you notice over here, this wire is a completely useless, I mean not useless, I would say. This wire has no resistance. So this resistance becomes useless actually, because it is now completely shorted. No current will go in this, because if current has a path to travel, an alternate path to travel with no resistance, it will prefer that path. So this is completely useless. This is completely useless. Understood? Okay. Now this 2 ohm and this 2 ohm, can you see they are both in parallel? Can you see that this 2 ohm and this 2 ohm, technically they both are in parallel. So in parallel 2 and 2 will become 1 ohm. This 2 and 2 will become 1 ohm. This 1 ohm is in series with this. This and this, they are basically in series with each other. So it will become 1 plus 2, which is 3 ohm. Now that 3 ohm and this 3 ohm, observe this now. It's going to get very interesting. This 3 ohm, whatever, here I got 3 ohm, and this 3 ohm and this 3 ohm, all are in parallel. All are in parallel. So what will be the equivalent resistance? It will be just 1 ohm. 3 by 3, which is 1 ohm. So that is just going to be 1 ohm. As simple as that. So looks very complex, but if you keep solving it, becomes very, very easy. Yep. Yeah. Yeah. Very good. Very good. You will get the notes, don't worry about gravitation and everything. And by the way, there are CBSE mock tests which are available for free of cost. Make sure you check out the links which are there in the description. And also please join the Telegram, because the latest updates and notifications will go live first on Telegram, and then you will get to know on YouTube too. But it's very important that you are a part of our Telegram channel. So make sure you join it as soon as possible. All right. So we'll meet soon. And make sure you have smashed the like button for this session, and we'll be doing more such sessions. And let me know if you are loving these kind of sessions where we do only the high weightage topics and we are doing the problems on it, and we are seeing what are the concepts involved over there. So make sure you comment below and let me know. Okay, thank you very much. Bye bye, take care.